So you can take the ln from the very beginning. So you get ln of 2 to the power minus t over 4 equal to ln of AD over 325. So that means minus t minus t over 4 times ln2 equal to ln of AD over 325. So minus t over 4 is ln of AD over 325 divided by ln of 2, and it's the same as, if you do simplify, you get the same answer as the first solution, right? So is this clear? Very good. Now let me go to, that was page 3, page 4. Any question? Question 3. Oh, the question 3 on the top. Okay, so you have a earthquake with magnitude. So you have M1 with magnitude 6.2. And the next day, you have an earthquake so this is M1. Oh, and we don't know I1. I mean, we can't tell, but let's just keep it I1. In the next day, we have I2, another earthquake with triple intensity. So that means I2 is 3 times I1, right? Now, what is M2? So remember the formula that M2 minus M1 is equal to log of I2 over I1. Yeah, you can use the same thing. I mean, you're just switching 1 and 2. Sure. So let's say you just switch 1 and 2 basically. But if you write M1 minus M2, you have to write I1 over I2. Okay, so that means here, so M1 minus M2 is equal to log of I1 over 3 times I1. So that means M1 minus M2. What is log of I1 over 3 times I1? It's just log of 1 over 3, right? So this guy is just log of 1 over 3. But log of 1 over 3 is minus log 3, right? Let me write it here. Sorry. So this is log of 1 over 3, which is equal to minus log of 3. So that means M1 minus M2 is minus log of 3. So that means M2. So from this equation, it follows that M2 is M1 plus log 3. So you just compute log 3 with your calculator and then add it to M1, which is just 6.2. Then you get M2. Was it clear? So describe how the graph of f of x equal to log of the fourth root of x is related to log x. So here is a simple relation because f of x is just 1/4 times log x. So that means f of x is just 1/4 times g of x. So you have a vertical compress with factor 1/4. No, gx is log x. So that means you just have a vertical compress of factor 1/4. Yeah. Then, any other question? This page? Okay, so that's easy. So magnitude 5, magnitude 7, right? So that means, for example, M1 is 7, M2 is 5. So that means, again, the same equation. Remember that M1 minus M2 is equal to log of I1 over I2. So M1 minus M2 is 2. So 2 is equal to log of I1 over I2. So that means, so what is I1 over I2 then? If log of I1 over I2 is 2, that means I1 over I2 is just 10 squared, which is 100. That's it. So I1 is 100 times more intense than I2. So, does it make sense? Everyone?
I am slightly confused.
Okay, so next page. Any question?
Yeah, could you talk about question 2?
Question 2. Okay, so for question 2, so you have f of x, let's say f of x is minus 2 times log of 2 times x minus 3. So which is equal to, there are different ways to look at this, but one way is to say that this is equal to minus 2 times log of x minus 3, because 2 times log of x minus 3 is log of 2 plus log of x minus 3, right? And then you have minus 2 times log of 2. Yes, So what I'm saying, I'm writing on the top, log of 2 times x minus 3 is equal to log of 2 plus log of x minus 3. The sum of the two logs is the log of the product. Now the second function reads g of x equal to 2 times log of minus 2 times x minus 3. So that is equal to, again, 2 times log of x minus 3 plus 2 times log of here you cannot say log of negative 2 because it doesn't make sense. So you just have to keep it that way. Yes.
Is it okay if you just state the transformations?
Yeah, we can. I mean, that's also something. Yes. I mean, you don't. Yeah, so let's do that way. So, I mean, sure. So let's keep in the simple form, like here. Okay. So for f of x, so first you do log of x minus 3. Here, the most important difference between these two functions are the domains. Okay, but I will draw the graph, but let me tell you here at the beginning that what is the domain of f? What is the domain of f? Greater than 3. So it's the interval from 3 to infinity. How about the domain of g?
X is greater than negative 3?
No, because here you have minus log of minus 2 times x minus 3. So minus 2 is a negative number. That means x minus 3 must be negative. Then you have negative times negative becomes positive. So that means x minus 3 must be negative. Therefore, x must be less than 3. So for the domain of G are all x's that are less than 3. For f, all x's that are greater than 3. And here you see the main difference between f and g. So one goes like this way, another goes that way. Okay, now let me draw each graph. So first one, you have minus 2 times log of 2 times x minus 3. So 2 times x minus 3 . So what is first? Log of x minus 3. Log of x minus 3. So you know that the vertical asymptote of log is x equal to 0. But here you have x minus 3. So you do a horizontal translation, 3 units to the right. So imagine this is x equal to 3. So log of x minus 3 is just this guy. And this point is x equal to 4. When you do 2 times log of this, 2 times log of x minus 3, you do a horizontal compress, right? So 2 times log of this, it's quite the same, except that it's something like this. Sorry, no, log of 2 times x minus 3, not 2 times that. This is log of 2 times x minus 3.
It has a negative in front, it should be x-axis, right?
Yeah, so I didn't talk about negative. Now you have minus 2 times this. So here is just 2 times this. Minus 2, so you have to flip it around x equal to 3.
So the A is the last step, right? The number in front of the log, the A is the last step.
So this one is log of, just give me a second. This is log of minus 2 times. Oh no, why you said minus 2? There is no log minus 2, sorry. Why you said log of minus 2?
No, at the beginning, x equals to -2 log.
Oh, that's something else. Okay, now but because you have beside log minus 2, then you flip it around the x-axis. Yeah, that's right. So you just flip the blue one around the x-axis. Let me use another color. So flip the blue one around the x-axis.
Draw the graph. On the points.
Yeah,
Yeah.
this is log of, this is minus log of 2 times x minus 3. And then when you multiply by 2, so you just, again, a vertical stretch. But it's similar to this, just a stretch. Because I don't have a space, I don't repeat it. But it's similar to this shape, yes.
Do we have to draw the graph? Because there's not enough space. We just state the.
Please draw it in another paper. Now, the second one, you have log of minus 2 times x minus 3. So let me just quickly tell you, log of minus 2 times x minus 3, again, x equal to 3 is a vertical asymptote. So x equal to 3, this line, x equal to 3 is a vertical asymptote. But because you have log of minus 2 times x minus 3, so you have to flip it around x equal to 3. So you get something like this. Okay, so the negative sign inside the log tells you to flip it around x equal to 3. So you see here, the two graphs are roughly, one of them is this guy, the other one is this guy, you see? So first one, the main difference is their domain. Their domain is different. And then one of them is increasing, one of them is decreasing. Actually, both are decreasing, and never mind. Log x.
drawing the graph, should we draw all the processes of the graph?
No, you don't have.
So just draw the graph.
Yes. So any question on this page? Question 3. Coffee? No. And then next question, yes? Any question? Is that clear? Okay. So now, is there anything about, in general, exponential and logarithm? Because we did lots of exercises and we did lots of examples. Is there anything you want me to discuss in more details?
Just give me more practice.
Yeah, just give us more practice.
I will give you one more assignment today. So you don't have any other questions?
For the bonus question,
Yeah.
is that the half-life one? Would the equation be 60 equals 68? 1/2 to the power t with u.
That's right. So it lose 8 grams means the mass is 60 now. So 60 equal to 68 times 1/2. The half-life is 3 years. But remember, this is, you have to keep track of the units. Here we work with years. So your answers is in terms of years. Mm-hmm.
The March 1st.
Mm-hmm. This is quite easy. So one magnitude is 9, the other magnitude is 7.2. So you can say that this is. Okay. Okay, so now I'm going to begin the trigonometry part and trigonometric functions. Okay, first, let me tell you something about angles. So in trigonometry, we use some different units or scales for angles. One is degree, another is radians. So let me write here, you have radian versus degree. So pi, remember pi is a number, is an irrational number. It's about 3.14 something. So pi radians is equivalent to 180 degrees. So that means 2 pi is 360 pi over 4, 45 pi over 3, 60 pi over 6 is 30 degrees. So in university and more profound, more advanced courses, it's more common to use the radians, like pi, 2 pi, pi over 3. So we don't use anymore 30 degrees, 60 degrees. So instead we have pi over 3, pi over 6, and so on. Okay? And you should know these angles from the unit circle. Let me tell you. So you have a circle. Okay, so let me begin with pi over 6. Pi over 6, 30 degrees is, let me use red, somehow like this. So this is, the angle here is pi over 6, right? And then you have pi over 3. Oh, sorry, pi over 4. Which is 45 degrees. And then we have pi over 3. And then we have pi half. So what I'm measuring, I measure with respect to the positive side of the x-axis. So my reference for measuring the angle is the positive side of the x-axis. So our reference for measuring angle is basically this line, the positive side of the x-axis. We usually deal with other angles like pi minus pi over 3, 2 pi over 3, for example. So 2 pi over 3. This is 2 pi over 3. Pi minus pi over 4, that is, what is pi minus pi over 4? 3 pi over 4. And then 5 pi over 6. So 5 pi over 6 is pi minus pi over 6. 3 pi over 4 is pi minus pi over 4. You see, the pi is, so theta equal to pi is this line. The negative side of this is theta equal to pi, right? So if you subtract pi over 6 from pi, you get 5 pi over 6. 3 pi over 4, 2 pi over 3, and so on. If you add pi over 6 to pi, you get 7 pi over 6, which is this line, this angle. So this is 7 pi over 6, which is basically pi plus pi over 6. And then pi plus pi over 4 is 5 pi over 4. And then pi plus pi over 3 is 4 pi over 3. So you must be familiar with these angles, especially you should know each one is located in what quadrant. So in the, because it's here is very important. I want you to master trigonometry. So in order to master trigonometry, you have to master the unit circle. This is called the unit circle. Unit circle is a circle with radius 1, with the origin located at the center. Yes. So this is called the unit circle. Circle with radius 1, its center is the origin. So you see, we know that the plane XY plane has 4 quadrants. Quadrant 1, quadrant 2, and 3, 4. So you should know each of this angle located in what quadrant. For instance, pi over 6, pi over 4, pi over 3, they're all in the first quadrant. Then 2 pi over 3, 3 pi over 4, 5 pi over 6, second quadrant, and so forth. I will tell you why these are important. So once I introduce the trigonometric ratios, then you will see that. Okay. Okay, now we introduce the trigonometric ratios. Again, we look at the unit circle. So if you have an angle theta, so this is a unit circle, first of all. So that means the radius is 1. So this is 1, 1, negative 1. So if you have an angle theta, and remember that we measure the angle with respect to positive direction of the x-axis. So we measure angle in counterclockwise way from the positive direction of the, so here is the positive direction of the x-axis. So we measure angle like this. Here is 0, pi half. Look at my hand. So 0, pi half, pi, and so on. Okay. So if this is the theta, then this point has x, y coordinates, right? This is x and this is y. So we define cosine of theta equal to x divided by 1, because here radius, which is the hypotenuse of this triangle, right triangle, is 1. So cosine of theta is just x. In this circle, cosine of theta is x over 1, which is equal to x because the radius is 1. And sine theta is equal to y over 1, that is equal to y. in general, if you have a right triangle with hypotenuse equal to r, if this is r in general, this is y, this is x, then cosine of theta is x over r, and sine theta is y over r. So some of the angles that we know from the past years, like 30 degrees, 60 degrees, and these things. So we know that some basic things is, so let me create just a table. So here I write theta, and then sine theta, cos theta. So for theta equal to 0, sine theta is equal to 0, cos theta is equal to 0. For theta equal to pi over 6, sine theta is 1/2, cos theta is root 3/2. For theta equal to pi over 3, which is 60 degrees, by the way, sine theta is root 3/2, cos theta is 1/2. For theta equal to pi over 4, which is 45 degrees, sine theta is square root 2 over 2, cos square root 2 over 2. For theta equal to pi half, sine theta is 1, cos theta is 0. And for theta equal to pi, sine theta is 0, cos theta is -1. So now look at the unit circle. Theta equal to 0 is this point. You agree? This point on the x-axis. This indicates theta equal to 0. So x coordinate of this point is what? Is 1, 0, y coordinate is 0. So that means cosine is 1, sine is 0. Now look at this angle, which is pi half, 90 degrees. This angle is pi half. What is the xy coordinate? X coordinate is 0, y coordinate is 1. That means cosine of pi half is 0, sine is 1. Now look at this point, theta equal to pi. X coordinate is -1, y coordinate is 0. So cos of pi is -1, sine of pi is 0. So you should be able to read angles from the unit circle. This point represent what? Theta equal to 3 pi half. So this guy is right here. Theta equal to 3 pi half. So what is the cosine of 3 pi half? Cosine is the x-axis, the x coordinate. What is the cosine of 3 pi half? X coordinate. 0. What is the sine of 3 pi half? -1. Exactly. Now 2 pi, you go back at 0. So that is why these are called periodic functions. Because at 2 pi, you go back to the point theta equal to 0. So it repeats the whole thing. So here is theta equal to 2 pi, which is equal to 0. So that means cosine of 2 pi is 1, sine of 2 pi is 0, right? Okay, so another thing, so as I said, so these are some angles that you should know. But what about some angles like 2 pi over 3, 3 pi over 4? So here I give you so just think, what is the cosine of 2 pi over 3? So 2 pi over 3 is pi minus pi over 3. So let me draw it here. So this angle, or maybe more precisely, this one is 2 pi over 3. So theta equal to 2 pi over 3. So this is located in the second quadrant. In the second quadrant, x is negative, y is positive. Okay, so in this quadrant, it means that cosine is negative. So in this quadrant, cosine is negative, but sine is positive. In the first quadrant, both are positive. So cosine and sine are both positive in the first quadrant. In the second, cosine is negative, sine is positive. In the third, both are negative because x coordinate is negative, y coordinate negative. And in the fourth quadrant, cosine is positive, but sine is negative. Now, could you, based on what I just said, so now look at 2 pi over 3. 2 pi over 3 is pi minus pi over 3. So the x coordinate for 2 pi over 3 is negative the x coordinate of pi over 3, because let me just show you pi over 3 and compare it to 2 pi over 3. So this is pi over 3. Do you see? So what is the relation between x, y coordinates of pi over 3 and 2 pi over 3? So this is pi over 3. This is 2 pi over 3. So this is just pi minus pi over 3. Yeah, but they have the same y values. You see, those points have the same y coordinates. The x coordinates are negative on each other. So that means for 2 pi over 3, cosine is just negative 1/2. So cosine of 2 pi over 3 is negative 1/2, which is negative cosine of pi over 3. And sine of 2 pi over 3 is the same as sine of pi over 3. You don't need to memorize. You can imagine the unit circle in your head.
But you have to.
Pi over 3, 2 pi over 3 is here.
Yeah, but that's kind of memorized. You memorize the angles of that.
Okay.
I remember we have the charges, just CAST.
Okay. So now a good exercise is, based on what I've written here, this is enough for all other angles. So based on what I'm written here in this chart, so I want you to complete this chart for these values. So complete this chart with these values. So theta 2 pi 3 over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, 4 pi over 5, no, not 4 pi over 5, my bad. So 7 pi over 6, then 5 pi over 4, and then 4 pi over 3. So remember that these three, 2 pi over 3, 3 pi over 4, and 5 pi over 6, these three are in the second quadrant. But the next three are in the third quadrant. So I pause it. I mean that cosine of theta plus 2 pi is equal to cosine of theta. The same for sine So cosine of theta plus 2 pi. So therefore, so the conclusion is that hence cosine of pi plus pi, 2 pi plus pi over 6, so 13 pi over 6. This is just equal to cosine of 2 pi plus pi over 6, which is equal to the cosine of pi over 6. That is equal to root 3. And you can see for all other angles. So this is just an example. This is just one example. So now let me conclude our lecture today with some remark, and I'm going to ask you to think about this. If you don't get it, I can explain to you later. So remark, this is cosine of theta minus pi is equal to minus cosine of theta sine of Oh, sorry. Okay. So using this, the last two relation equation, I mean, cosine of theta plus, this is easy to imagine. Look at here. If this is theta, look here. If this is theta, this guy is theta plus pi, right? So the cosine and sine both becomes negative, right? This is theta. This would be theta plus pi.
Plus what?
Plus pi. So you see the cos and sine, because xy becomes negative here, right? Is that clear?
I think I got an easier way to
Right.
like all students take calculus, like A S T C. It is fixed in the work quadrant.
Cast.
All students take calculus.
What do you mean?
She's talking about
Like
how to
the
determine
capital,
what
it is positive.
when it's positive, negative, then the conjugate.
Yeah. But I'm telling you the reason. So if this is theta, I mean, you don't have, I mean, you can memorize, but if this is theta, see, if this is theta, this guy is pi plus theta, right? So you see xy here both becomes negative. That means cosine and sine both becomes negative. But here is pi minus theta. So theta, pi minus theta. Sine is the same, the y coordinates are the same, but the x coordinate becomes negative. Good. Now, based on this, you can see that it follows from these two, the last two equation, it follows from these two that tangent of theta plus pi is equal to what? Can you tell me? Tan of theta. So that means the periodicity of tangent is pi. So tangent of theta plus pi is tangent of theta. So it's a periodic tangent is the same as cotangent. So cosine and sine are periodic with the principal period equal to 2 pi. So this is called the principal period. I will tell you why it's called principal. So the principal period of cosine and sine are 2 pi.
When is lunch? It's already 2:30.
Yes.
When is lunch? When?
Okay. But the principal period for tangent is pi. I will explain why it's called principal period. Okay, guys? So I'm going to give you just one more assignment for log. It's not long. I have just to modify some of the questions. I will post it on the website after the lunch.
I have a question.
Yes.
You can explain the principal period right now, or?
Oh, the principle, because, so the thing is, yeah, it's not a deep thing. It's not a deep concept. So we know that we saw that sine of theta plus 2 pi is sine of theta, right?
Yeah.
But obviously sine of theta plus, I don't know, 6 pi is also sine of theta. Or sine of theta plus 100 pi is also sine theta, right? Sine of theta plus 20 pi is also sine theta. Right? But the question is, which one is the period? Because this is the smallest. So between all the periods, they are all periods because sine of theta plus 20 pi is also sine theta. 100 is also. But between all of them, 2 pi is the smallest. That means you cannot find something smaller than 2 pi, so that thing happens. So the smallest one is 2 pi. For tangent, the smallest one is what? What is the period of tangent? Principal period is pi. Yes, it is pi. Okay. It is also 2 pi, but the smallest one is pi. That's the point. But for cosine and sine, it's not pi.